Exomoons. They are a very rare thing in the universe. There are only 3 that we know of. They are extremely hard to find with the technology that we have today because they are so far away. Even some scientists think they found some, but they were proven wrong with lots of different points of data. There are many stages you have to go through to prove that you have found a exomoon. Science is a very long topic filled with many different things. In science, there is always more ways to prove a theory than you think. It is a struggle to prove something in science, like it is hard to prove the finding of an exomoon. But the real question is, first, we probably need to ask who discovered the first exomoon. The 2 people who discovered the first exomoon was Alex Treachery and David Kipping. There is not a lot of information on Alex or David. As I found, David Kipping was born in 1983. David is an astronomer and assistant professor at Columbia University, just like Alex. David went to University College London to get the academic degree Doctor of Psychology. He went there for 5 years. This is the University of Columbia they worked at. They discovered the first exomoon back in 2017. They were looking at an exoplanet, Kepler 1625b, but they discovered there was an exomoon orbiting the exoplanet. It took them 1 year to confirm that it was an exomoon and publish their findings. In 2019, their research was reanalyzed, but there was nothing to confirm it was not real. They called the exomoon Kepler 1625b-. I know, not that exciting for the name for the first exomoon. But hey, that's what they named it, so can't change it. They used 2 different telescopes. The first telescope that was used was the Kepler Space Telescope. The second telescope was the Hubble Space Telescope. The only problem with the telescopes was the telescope turned every 3 months, so the pixels were never in the same location they were in. Now, before talking about how they were discovered by astronomers, let's talk about how light intensity from a star decreases when a moon is in front of it. When a moon passes a star, it is blocked out parts of the star, making the light from the star decrease in intensity. That is how some planets and moons are found in the universe. The bigger the object, the more the star is blocked out for us. To know if it is a planet or moon, astronomers have to see if it is in routine. Then there's other data that needs to be run through to confirm it is actually something. If the other data does not add up, then it's just some random rocks going through the star's vision for us. That is one of the ways things like exomoons are falsely discovered and discovered. Sometimes it is just the telescope acting up, but only sometimes. Sometimes it's just an astronomer making false planets and moons because they want to discover stuff. Maybe. It's just a theory. Now, How do moons get found by astronomers? The first discovery happened in Cool World's lab. The first evidence that shows that there's an exomoon is a timing offset. The transit never occurred every orbital period. It changed every 20 minutes, sometimes arriving earlier, sometimes occurring later than expected. This is known as TTVs, or transit timing variations. This is a cause of an exomoon by the exomoon's gravitational pull on the planet, which does not show enough evidence because it can be another planet causing the effects, as shown here. There was a second dip in starlight from the data, consisting of the exomoon passing in front of the star, showing a second decrease in starlight. It can't be completely proven yet with the data because they only have one good transit of the moon. Also, it can not be proven that the telescope did not malfunction. But the data came from the Hubble Space Telescope that only had 40 hours of data. And the telescope they used is known for malfunctions. There was never a moon that had ever thought to be that big. So, it might look like these exomoons or moons like that can't be real, but they look for moons that are big and are further away from a star, and there's moons that are big as, so maybe there is still hope. So they made a survey that had to meet the criteria for it to be a exomoon. They have to have an orbit wider than the Earth. They had to be at least half the size of Jupiter, and they had to at least 2 record transit by Kepler Space Telescope. The only problem with the transit is to show all kinds of extra wiggles from the changes of the telescope and the intrinsic variability of the stars. These astronomers have found a way to correct those effects. It is called method modelizing deep trending. Many different astronomers made different approaches to fix the problem, so they used all their data to correct the error, and they made a vote on which one was correct. Next, they went through the corrected light curves and fit different physical models to the data set. He asked, how does a planet itself explain the data against a planet with a moon? For it to be an exomoon, it has to be 10 times more likely than the planet by itself. This is known as the Bayes factor. This factor is why it has to be so high, because it would be considered strong evidence in model selection studies. Then it has to be at a critical orbit for a planet, because high Euclid orbit are thought to be unstable location for exomoons. Sometimes when a planet passes through a star, it goes by a star's spot, making it like there is a moon there. For one of the ways to confirm an exomoon is looking at the noise property of the transit. Astronomers also look at the timing to see if the timing is off by too much. Injection recovery is also used. Injection recovery is when you inject a known truth like a planet, then push it through the entire pipeline discussing if the planet has an exomoon. Then see how often we conclude there was an exomoon. The resulting number is called the false positive probability, or FPP. It is the probability that the astronomer are wrong. This is the injection recovery process. For the last 3 decades, thousands of planets have been discovered, and more in the future. There are only 2 exomoons that have ever been discovered throughout history. Kepler 1625b-I and Kepler 1708b-I.
How much you downloaded?
I'm going to go over what I went over so you won't forget. So exomoons are extremely rare. There are only 3 that we know of, but there are more to find out there. Our technology limits how far we can get in our universe, but we use stars to find new planets and exomoons. We would have never found thousands of planets and moons and other things in our universe. But when something is thought to be discovered, it might just be a star spot or the telescope messing up, so you have never be truly sure. But you have to go over many different trials and get more data to be sure. The astronomers who discovered the first exomoon were Alex Treachery and David Kipping. They both worked at the University of Columbia. David went to University College London for 5 years to get his Doctor of Philosophy. They discovered the first exomoon back in 2017. It was officially named Kepler 1625b-I. It took them 1 year to confirm it was an exomoon and publish their findings. In 2017, the exomoon was reanalyzed, but they found nothing to show that Kepler 1625b-I was not an exomoon. There are 2 telescopes that were used to locate exomoons. One of them were the Kepler Space Telescope. The other telescope is the Hubble Space Telescope. The problem with the Hubble Space Telescope is it turns every 3 months. So something that was at one spot on the telescope changes to another location. When a planet or moon goes in front of a star, the light intensity decreases because of the blocked out part of the star. The larger the object is, the more the star is blocked out. So no, it is not the telescope messing up or the star spot, it must have a routine. If it has a routine being there, it might be a planet or moon in front of the star. Sometimes it goes unnoticed and becomes a false planet or moon. The first discovery of an exomoon was at Cool World's lab. The first evidence was a timing offset in its rotation around the star. The offset was 20 minutes, arriving 20 minutes early or 20 minutes late. This is known as TTV, or transit timing variation. It is also caused by exomoon gravitational pull of its planet. Starlight research is also used. It can be seen by dips on the charts when passing in front of the star. At least 2 transits have to be recorded to be confirmed by the transit research. Because if it is only one, it might be a malfunction like the research from the Hubble Space Telescope, because the telescope is known to malfunction.